All right, so in this example, we're going to be rationalizing and simplifying the following expression. 3 over the 4th root of 2x, where we're specifying that x is going to be positive. And that'll make sense in a few minutes because we're going to have to worry about potentially absolute values when we cancel out that 4th root. Okay, so how does this work out? It's going to basically work out the exact same way as the last couple examples. So we're looking at 3 over 4th root of 2x, and we're going to cleverly multiply by a special version of 1 that allows us to cancel off this radical here. So we're going to power up this 2x on the inside. We have to power it up just enough to cancel off this 4th root. So we have 4th root of 2x quantity cubed. So it's the whole quantity that's getting cubed here. We want everything in here to be big enough so that when I multiply these guys in the denominator, I can cancel off the 4th root. So I have 2x cubed here as well. So what does this buy me? Multiplying straight across the top as you normally would with fraction multiplication. We have 4th root of 3 times 4th root of 2x quantity cubed. And then in the denominator, I have the same power on both of these guys here, the same radical. So using the product rule for radical expressions, this gives me one big radical with 2x from this guy times 2x cubed from this guy. So how many 2x's do I have in this case? The answer would be 4. Doing that, rewriting that, so I have basically copy-paste the numerator here. In the denominator, I have the 4th root of 2x quantity to the 4th power, okay? Because I have 4 of them in total. So now I have a 4th power of something and a 4th root. They cancel each other. But we got to be careful because, well, you have an even root and an even power. So normally, if I did not specify that x was greater than 0, which I did at the very beginning of this, we would have to put this in absolute value bars. But since I said that x is greater than 0, we don't have to worry about that because x is only going to be a positive number. Okay? So, rewriting it this way, we have 3 4th root of 2x cubed all over just 2x because we canceled the 4 and the 4th root. Okay? So now this expression, I have 3 over 2, but I can't cancel these guys because I don't have a factor of 2 inside 3, nor do I have a factor of 3 inside 2. So I can't really cancel these. Here, I have 3 2x's. I need 4 to cancel this. So I'm stuck with this expression as is. Furthermore, I cannot cancel these x's because these are stuck inside the radical. Anything that's inside a radical is, in a sense, locked inside that radical. Okay? So no cancellation, nothing weird going on here. We are literally stuck with what we have. And with that, this example is done. And we'll look at a similar one in the next example video.